Hey everyone, welcome back to the channel. Today we are going to see the problem remove duplicates from sorted array. And here is the problem statement. Given an integer array nums sorted in non-descending order, and we have to remove the duplicate in place such that each element that is duplicated, we have to remove it and it should appear only once. Okay, and here the word in place, it means we don't have to use other arrays or other list for it. We have to do it is a memory optimized program. Okay, and here the second thing is the relative order of the element should be kept in the same. So our relative order should be the same, and we have to return the number of the unique elements in the array nums. Okay, so let's see the example. They have shown some example. So you can see here, this is the example first, that is nums, and it has 1 1 and 2. This is our nums array. Okay, so here it will return 2 because it has only two unique values, that is 1 and 2. And our final array in memory, it should be like this: 1 2, and whatever you kept after that doesn't matter. Okay, so here it is the second example. You can see here 0 comes 2 times, 1 comes 3 times, 2 come 2 times, 3 come 2 times, and 4 come once, right? So our final array will contain 5 unique elements. So here you can see 5 unique elements, and we have to modify the array in such a way that it should return like this: 0 1 2 3 4, and whatever you keep after that, that doesn't matter. So how we can approach this problem, or how we can solve this problem? So first thing, we can solve this problem by comparing current element and the previous element. So here you can see, if we think about the first element, every time the first element will be the unique element, right? So we can start from the second element of the array. So this is our second element, and we have to find this second element comes only once or not, or it is the next unique number or not. So it is the sorted array, so that's why we can compare this element with its previous element, and if it matches with the previous element, then it is not a unique, and if it doesn't match, then it is a unique. So here you can see, if 0, we start here, 0 and 0 don't match, so no unique. But we come on next pair, that is 0 and 1. So here the current element will be 1 and the previous element will be 0, so they don't match. So this is the second unique number, and it will come here. Then we come after that to this pair, that is 1 comma 1 pair, and here now the current element is this one, right? So this one should match to this element. Yes, it is matching, so this is not a unique element. Then we have to move one step ahead, and in this way we can solve this problem. So I will code the problem first, and then I will show you the dry run of the problem. Okay, we can solve this problem with the help of two pointer method. So we can create a one left pointer and one right pointer, and we can keep left pointer at same place where the unique element has to be placed, and right pointer we will move ahead one by one, and then we will compare the current element, that is the right pointer's element, and its previous elements. Okay, so how we can solve this? So here they have already created the class, and they have given us the nums. Okay, so now let's start solving the problem. So first we need a pointer, right? We need two pointer to solve this problem. So our first pointer is left pointer, so let's call it is L, and that is equals to 1. Okay, now our second pointer is R, but we can initiate it in the for loop itself. So I'm going to iterate over the array, that is for R, that is our right pointer, in, then range, we have to iterate over the length. So we have to iterate from first point to length of the array. So length of nums. Okay, now we came inside. Okay, so after that we have to check the current element and its previous element are not same. If they are not same, then the current element is the next unique element, right? So if nums of R that is right pointer's current element, and if it is not equal to nums of r minus 1, that is the previous element, right? If they are not same, so in that scenario we have to place the current element to the left pointer's position or unique position. Okay, so nums of left pointer, that is this, and that we have to assign nums of r. Okay, then after that every time we move one by one step, right? And if we found the element, then we have to if we found the unique element, right, and if we place that unique element at the current left pointer's position, then we have to increase the new left pointer position, or we have to go to new left pointer position, and that is one more than the previous position. So that's why L equals to L plus 1. Okay, and if this condition doesn't matches, in that scenario we have to increase r equals to r plus 1, because in every iteration our r need to be move ahead so that we can check new values from the array, but that is taken care by the loop or for loops iteration itself. Okay, so no need to write that thing. So just now here you can see our L pointer's position is continuously increasing, right? So whenever array comes at the end, then the L pointer will be at the last unique values point, and that we have to return. So here return L. Okay, now let's run our solution, and you can see all the test cases are passed, right? So let's dry run the problem over this array. Okay, that is 0 0 1 1 and everything. So I have created that array in Excel, you can see here. And now let's see how we can solve this problem. Okay, so I'm going to do it here, and this is our problem. So our first left pointer will be at first position, right? So this is our first position, so I will keep L here. Okay, now we are iterating for r in the range 1 to length of array. So r's value also here, r's first position will be this. Okay, now you can see num of r, that is 0, that should be not equals to num of r minus 1. So r minus 1 is this position and its value 0. So 0 equals to 0. So this condition will false and it will go to the next iteration. Okay, so in the next iteration r's value become here, r's value become 2. Okay, and our new position of r is this. Now it will come to this if loop. Num of r, that has value 1, that is not equals to num of r minus 1. So now r minus 1 is 0 and num of r is 1. So it is not equals to. So if it is not equals, then in that scenario we have to replace the value. So our num of L. So here num of L, we have to replace num of r. Num of current r is 1. Okay, so this is 1, right? Now loop is come. We have to go to another iteration. So next iteration r becomes this. R's value is 3, and now L's value is this 1. Okay, this is our new L. So here it will again check this num of r is not equals to this. Yeah, it is not equals to. Then it simply go to the next, and that's r's new value is this. It will again check if current r and left pointer's value both are same. Yes, both are same. It will skip the if block and it will iterate to the next. Okay, so it came here. Now it will check num of r and num of L. They are equal? No, they are not equal. And if they are not equal, it will replace the num of I or the num of L to num of r. So num of r's value, that is 2, that has to be at the num of L at this place. And we have to increase L with next one step. Okay, or at next memory location. So it will again go and it will check r's new value is this after this loop. Okay, so it will check yeah. Okay, so it will check num of r, that is currently 2, and num of r minus 1, that is 2. So yes, they are matching, so it will skip the if block and it will, r's new value is this. Now it will check num of r is 3 and num of r minus 1 is 2. So in that scenario it's not matching, right? If it's not matching, then num of r will be placed at the this position, that current num of l position, and num of l or the else value will be incremented. So this is our new L, right? So in the next iteration, you can see R's value is this. So it will compare R and R minus 1's value are same. Yes, it is same. So now R's new position is this, and now it will check num of R and num of R minus 1. Yes, they are different. And if they are different, it will place the num of R to num of L. So it will place 4 here. Okay, and this is our next position of L. Okay, okay, and after that the list is ended. Okay, so we will come out of the loop, right? So now you can see it will iterate it 0 1 2 3 and 4, and now r's position is 5, right? So it will return 5. So 5 are the number of unique elements in this list. So in this way we can solve this problem. So this is all for the today's video. If you see any difficulties in the explanation, then feel free to ask the questions in the comment section below, and I will see you in the next video. Till then, keep learning, keep growing.